What I want to do now is I want to go through and provide a bit of a review in terms of where we are in the overall progression of the course. And I guess in a way you could think about this as being the big picture, putting things into perspective in terms of what we've covered and how much more is left. So I like to refer to this as being where are we? Now, to give a bit of a review, we started the course by looking at properties. And that is the properties of a number of different substances or fluids typically that are the working fluids of the cycles that we've been analyzing. And when we looked at properties, we looked at things such as how to calculate enthalpy, specific volume. Quite often these were in the property tables. Internal energy, and the fluids, or the liquids that this was applying to, we looked at steam, R134A, as well as ideal gases. So that was one thing that we've covered thus far, and it was where we started. We then went and we looked at the first law, and we looked at two forms of the first law. One was for fixed mass, and the other was for control volume application, where you have mass crossing the boundaries. But when we were looking at the first law, we looked at the concept of energy transfer. And energy can be transferred in a number of ways: through work, heat, as well as mass, in the event that we have mass crossing our control boundary. And we looked at systems that were fixed mass or closed systems. We also looked at the first law for two different types of systems, fixed mass, like I just referred to. So we looked at applications where mass does not cross the control boundary. And we also looked at applications where mass would cross the control boundary, and that was the control volume approach. And we also looked at uniform flow processes. Other things that we looked at, we've covered entropy. And we looked at entropy in two different ways. We've looked at it from the qualitative perspective. So that is, what is entropy conceptually? And we also looked at it from a quantitative perspective. And those would be looking at things such as entropy balance or entropy generation. The next area that we went into was exergy. Useful work potential, second law efficiencies. Those were the things that we looked at with exergy. These together, all of these are what I would refer to as being the fundamentals to any type of thermodynamic application. And that's why when you're solving and working problems with these, they can sometimes seem a little bit on the abstract side. You're equipping yourself with the equations and with the procedures and the tools to be able to study real-world applications. And so that was the first part, and that's what all those lectures were devoted to. We then moved into what I would refer to as being the applications. And the applications that we've considered thus far have been gas power cycles. And here we looked at the Otto cycle, diesel, Stirling, and the Brayton. So those were the different gas power cycles that we looked at, and for those what happens is the working fluid remains a gas and it does not go through a phase change. Other power cycles that we looked at were vapor power cycles, and with these power cycles the working fluid does go through a phase change. And the ones that we looked at were the Rankine and then derivatives of the Rankine. So reheat, regen, and cogen. We also had the mixed cycle as well. So those are the applications that we've looked at thus far. In the remaining lectures, what we'll be doing is looking at a few more applications within thermodynamics, mechanical engineering thermodynamics that is. So we're going to be moving on into refrigeration, HVAC, and we'll have to look at gas properties and mixtures before we can get to HVAC. So in a way, we do go back to a little bit of the fundamentals there. HVAC, so heating, ventilation, and air conditioning. And finally, we'll move onwards towards combustion. So we'll be looking at systems whereby we have chemical reactions, notably combustion and oxidation reaction, typically of hydrocarbon fuels. So these are the areas that we have left to cover within the course. And we've gone through two main applications, gas, power, vapor, and we have three main left. So that gives you an idea as to where we are in the course. We've covered the fundamentals or the basics, looking at properties, the first law, entropy, and exergy. And then we've gone into applications, and we have a number of applications left. So that concludes the lecture as well as vapor power cycles.